Let's talk about particles as well as the free body diagrams of these particles. Particles are objects that the size is relatively small compared to the rest of the forces or the problems that you might have. So for that reason, we can consider them just as a point in space. Later on, we're going to see what rigid bodies are. In those cases, then we're going to have some sizes of these rigid bodies, and that's going to have an effect on our analysis. But for these particular problems, we're going to consider only particles. So there are bodies that are small enough that we'll only consider the forces going through that particular point in space. Now, free body diagrams are going to help us analyze these systems or analyze these particles because it shows the forces acting on the particles only, right? And they're going to be essential for us to be able to write our equations of equilibrium. Now, there are three things that we need to take in consideration when writing these free body diagrams. The first one is we only want to draw the diagram of the particle in question, nothing else. We want to draw the forces acting on that particle. And last, we want to draw the axis that's going to help us define the direction of the forces acting on that particle. So let me write that down just for completeness. So for these free body diagrams, and in this particular case of particles, the three important things are that we're going to have the draw the particle only, nothing else. If there are cables connected to that particle or there's any supports, those are not drawn, only the particle in question. The second thing that is important is to draw the forces acting on the particle. Only the forces acting on the particle. And last, we want to draw our axis. Always remember to do your axis so we know the orientation of our forces. So those are the main things. So for this, let me consider the picture that is going to be on the screen. In this particular bridge, what we're going to do is we're going to draw the free body diagram of one of the connections of those cables. So let's consider the first cable that we see, the first vertical cable that we see on the left hand side. And when we look at that cable, that is connected with some other cables on top. So let me do this as an example. So if I want to do a diagram of that cable, this is what it's going to look like. So now this is the cable with the connection. So the cable with the connection, I'm going to see something like this. This is my cable, this is the connection, and that's the other cable. And then there is a cable that comes over here like this. And then the rest of the bridge continues, right? So there is another cable coming from here, right? And then the deck of the bridge is connected between those two cables. So that's the deck of the bridge, right? Now, when we're looking at particle equilibrium or looking at the free body diagram of these particles, the first thing that we need to do is identify the particle in question. And let's say that my interest is in looking at what's happening in this connection over here. So for that reason, the particle in question is going to be this particle over here, right? Let's say that this is A. Let's give it a name. So now for my analysis, I can do my free body diagram of A. So my free body diagram of A. All right, so let's follow the steps. The first step is to only draw the particle. So I'm gonna do my particle over here. Now the next thing is to draw the forces acting on that particle. So I'm gonna use, let's try green and see how that looks. All right, based on that plot of the diagram on the top, I see that I have a cable coming in this direction, and that's gonna pull my particle in this direction. There's another cable going in this direction that's gonna pull my cable in that direction. There's gonna be a cable in this other direction, and that's gonna pull my particle in that direction. I'm gonna put some names to these forces. So I'm gonna call this F1, call this F2, I call this F3. And then the next part is to be able to label my axis. So in reality, this is a 3D problem, but for simplicity right now, I'm just gonna say, let's assume that this is 2D. Let's assume that those 3 cables are defining a plane. And let's say that I'm gonna define my x-axis in this direction, my y-axis in this direction. All right, so I'm doing that on purpose, not horizontal and vertical, just to show you that the axis can be defined in any direction. Other things that I can do is I can start defining some angles. All right, that's theta, perhaps this angle over here is alpha, this angle over here is gamma. And with those definitions of the forces, the definition of the axis, and the angles, we have a full free body diagram. So that free body diagram is showing the particle, the forces acting on that particle, as well as any other additional information that is going to help us solve an equilibrium problem.